Here we're going to name ionic compounds. Recall that an ionic compound contains both a metal and a nonmetal species. An ionic compound is composed of ions. So for example, neutral atoms have equal numbers of protons and electrons. Up to now, we've been talking about neutral atoms. Protons have a positive 1 charge, electrons have a negative 1 charge. The sodium atom has 11 protons and 11 electrons. So that means 11 positive charges and 11 negative charges. These add up to 0. So that means the sodium atom is neutral because it has a net charge of 0. Ions are atoms that have either lost 1 or more electrons or gained 1 or more electrons. So examples of atoms that lose 1 or more electrons would be sodium, magnesium. In fact, metals tend to lose electrons. So notice here that sodium has a +1 charge, and that's because sodium has lost 1 electron. Magnesium has a +2 charge, and that's because magnesium has lost 2 electrons. Here are some examples of atoms that have gained 1 or more electrons. Notice that chlorine here has gained 1 electron, so now it is an ion with a -1 charge. Oxygen, when it gains 2 electrons, it becomes an ion with a -2 charge. Atoms like sodium and chlorine will form just 1 ion. There are other atoms that can form more than 1 ion, and what we mean by that are ions of different charges. So chromium can form a +6 ion, a +3 ion, a +1 ion, and so on. Ions that are derived from single atoms are called monatomic ions. Polyatomic ions now are composed of more than 1 atom. One example is the sulfate ion. Notice that it is composed of nonmetal atoms and it has a charge associated with it. The charge is associated with this whole unit. We will talk about polyatomic ions much later. We call positively charged ions cations, and negatively charged ions are called anions. Metals tend to form cations, and nonmetals tend to form anions. There are 3 rules for naming monatomic ions. Number 1, ions with a negative charge. Find the element name, and then what we do is we drop the ending and add the "ide" suffix, and then the word ions. For example, chlorine gains an electron and becomes the chloride ion. Sulfur gains 2 electrons to become the sulfide ion. Number 2, metals that form cations of only 1 charge are named as the element name plus the word ion. So for example, when magnesium loses 2 electrons, it becomes the magnesium ion. When potassium loses 1 electron, it becomes the potassium ion. Number 3, metals that form cations of more than 1 possible charge are named by the element name, and then we use a Roman numeral to indicate the charge on the cation, and then the word ion. So for example, when iron loses 2 electrons, it becomes the iron 2 ion. When chromium loses 3 electrons, it becomes the chromium 3 ion. We can predict the charges of many of the ions formed from groups 1, 2, 6, and 7a. Here's part of the periodic table here. You will need to know the charges on many of these ions. So in group 1a, the metals form ions with a +1 charge. In group 2a, they form ions with a +2 charge. In group 3a, a +3 charge. In group 5a, they tend to gain electrons to become charged anions with a -3 charge. Group 6a -2 charge, and group 7A, a -1 charge. For the transition elements and elements on this side of the periodic table, the metals that is, they can have different charges. So how do we write formulas and name ionic compounds? First thing we have to realize that prefixes are not used when naming ionic compounds. So magnesium chloride is named as magnesium chloride and not magnesium dichloride. Why? Because for an ionic compound, there's only one way that the two species, the metal and the non-metal species, can combine. Remember, both species are charged. When we're dealing with charged species, then they can only combine in one way. Why? Because compounds are neutral. There can be no net charge. So the charges must balance, or they must add to 0. Some important rules. All compounds, both covalent and ionic, must have a net 0 charge. When writing formulas and naming ionic compounds, the metal is named first. Here, we're going to write the formulas for some combinations of ions, and then we're going to name the compound. So let's go ahead and look at the combination of magnesium and nitrogen. So what we want to do is we want to write the formula and then name the ionic compound that is formed from the elements magnesium and nitrogen. Now, here I have part of the periodic table. And again, notice that the ions that are formed from the elements in group 1A all have +1 charges. In 2A, +2 charges. In 3A, aluminum has a +3 charge. In 5A, nitrogen and phosphorus tend to gain electrons to be a -3 charge. Group 6A, -2 charge. Group 7A, -1 charge. You should be able to determine some of these charges, okay, just by looking at group numbers. Now, the transition elements and then metals below here in the lower portion of the periodic table can have more than one charge. Okay, so notice here tin has a +2 and a +4 charge. Let's go ahead then and write the formula and name the compound that would be formed from magnesium and nitrogen. Now, we know that magnesium is in group 2A and will form a +2 ion. And then nitrogen is the nonmetal. Remember, nonmetals tend to gain electrons, and this has a -3 charge. Okay, so now what we want to do is we want to combine these in such a way that the compound, the ionic compound, is neutral. We have 2 positive charges here and 3 negative charges. So the way I would write the compound is like this. I am going to need 3 magnesium ions, okay, for every 2 nitrite ions. So how do I know that this is neutral? Well, magnesium has a +2 charge. I have 3 magnesiums, so 3 times a +2. And again, remember, the charges must add up to 0. Here I have 2 nitrogens. Each nitrite ion has a -3 charge, so that's going to be 2 times a -3, and then these add up to 0. So that's correct. Notice that the charge on the magnesium ion becomes the subscript on the nitrogen, and the charge of the nitrite ion becomes the subscript here. Okay? Basically, I can draw these arrows to show that. Now, let's name this compound then. From our rules, we know that our metal then would be named as magnesium. And here we have a -3 nitrite ion. Remember, we use the "ide" ending, so this would be magnesium nitride. Let's try another one. How about the ionic compound formed from aluminum and oxygen? So aluminum is in group 3A, and it will form a +3 ion, and then of course oxygen will form a -2 ion. So aluminum is our metal, it's going to lose the electrons, and oxygen is our nonmetal, and it gains the 2 electrons. So let's write the ions then. So aluminum loses 3 electrons, it has a +3 charge, and then we have our oxide ion, and that has a -2 charge. Now we need to combine these in such a way that the charge on the compound is neutral. So I'm going to cross these over. So I'm going to write aluminum, and then oxygen, and a 3 subscript. And we can check this to make sure that the compound is indeed neutral. We have 2 aluminum atoms, and the charge on each of those ions is a +3. We have 3 oxide ions, each with a -2 charge, and again, this adds up to 0. So we have the correct formula. How do we name this? We have aluminum oxide. Remember, the nonmetal gets the IDE ending. Let's do one more. And let's look at the combination of sulfur and cesium. Okay, now be careful here. Sulfur is a nonmetal, cesium is a metal. Okay, so it's the metal that loses the electrons, and cesium is in group 1A, so it's going to have a +1 charge. So cesium is going to be a +1, and sulfur is in group 6A, and it's going to have a -2 charge. In order for this compound to be neutral, I'm going to need 2 positive charges and 2 negative charges here. So we write the formula as, and again, basically the charge here becomes this subscript, this charge becomes this subscript. So we have 2 cesium ions and 1 sulfide ion that combined. And we can check this. We have 2 cesiums, each with a +1, and 1 sulfur that is a -2. And this adds up to 0. And we would name this cesium sulfide. Let's go with calcium and oxygen. So calcium has a 2+ charge, oxygen a -2. Now, when the magnitude of both charges are equal, as they are here, here we have a 2, here we have a 2, we just go ahead and write the formula. And this would be called calcium oxide. And we can check this. We know that oxygen has a -2 charge, and calcium has a +2. So a +2 plus a -2 equals 0. Now, what if I asked you to name this compound here? So here our metal is strontium, and here we have chloride. Iron 2 chloride. Remember, now this is one of those atoms that forms an ion that can have more than 1 charge. So in this case here, the iron has a +2 charge. Okay, the Roman numeral tells us that. And of course, chloride ion has a -1 charge. So again, I would write this as iron So we have 2 chloride ions for each iron ion. So, and we can check this. We know by looking at the formula, okay, remember how we crisscrossed these charges and they became subscripts? Well, we know that this 2 here would be the charge on the iron, and of course the charge on the chloride ion is a -1. Let's try another one. How about this one? Tin for chloride. Again, this Roman numeral pertains to the charge on the tin. So that would be tin with a +4 charge. And we know that chloride ion has a -1 charge, so we would write the formula like so. And again, we can check. So we have 1 tin ion with a +4 charge plus 4 chloride ions that have a -1 charge, and that equals 0. Let's do another one here. What is the name of this compound here? This is the symbol for silver. This is the symbol, of course, for chloride. So this would be called silver chloride. Silver is a transition metal, but it only forms ions with a +1 charge, so we don't need the Roman numeral here. Let's try this one here. Why don't you name this compound? We have iron, and this is one of those transition elements that can form ions of more than 1 charge. So here we have iron as the metal, and we know iron is a transition element, and therefore it can form ions of more than 1 charge. So by looking at the formula, remember this subscript here is going to be the charge on the iron. So the iron in this case is going to have a +3 charge, and of course the oxide anion has a -2 charge. Okay, so we would call this iron 3. Again, the Roman numeral 3 corresponds to the charge oxide. Let's try one more. Our metal here is cobalt, and our nonmetal is sulfur. And so this is an ionic compound formed from cobalt cations and sulfide ions. So now we have to determine the charge. Well, cobalt is one of those elements that form ions of more than 1 charge, but we do know that the sulfur has a -2 charge. So the sulfur has a -2 charge, okay? Well, since we only have 1 of each, that must mean that the cobalt is a +2. So we would call this cobalt 2 sulfide, okay? How about this one? The metal is copper, and then of course we have chloride ions. So in this case here, again, this subscript here refers to the charge on the copper. So we would have a +2 charge on the copper, and of course a -1 on the chloride. So we would call this copper 2 chloride. And let's take a look at one last one here. Let's take a look at this one. Here we have 2 copper atoms and a sulfur atom. So in this case here now, the subscript, of course, is the charge on the sulfide ion. And we know that sulfide ion has a -2 charge. We have 2 coppers here, so that must mean that the copper has a +1 charge. Or we don't see a subscript here with the sulfur, so we assume a 1. Copper has a +1 charge. This one would be called copper 1 sulfide.